in the Filecoin space and adjacent technologies, and then talk a little bit about why I think it's really important in the much broader picture about what's happening on the internet and in society. And I'll just leave a couple of nuggets there, but hopefully it's enough to get you thinking and maybe digging into it in different ways. And hopefully it inspires some of your hacks this weekend even. So yeah, it's kind of a grandiose title, Filecoin and the Future of Data on the Internet, but I hope we get there. So I'm Andrew. If you made it to my workshop on Thursday, you'll know already that I work at Textile. We build developer tools primarily for using IPFS and IPFS Stack and for using Filecoin now. And you can find me on Twitter at AndrewXHill. You can find everything about Textile at textile.io. You can join our Slack, and I'll remind you this at the end, but we're hiring as well. And so on the website, you'll find a link for our hiring page to learn about the roles that are open right now, and we'd love to hear from you. So let's just jump right in and kind of build up a little bit of the story for Filecoin and what's really interesting in this space for you to dig into. I'm going to break this up into more or less 3 parts, which are IPFS to Filecoin and kind of thinking about those technologies and what's really interesting from both. Then I want to talk a little bit about the client side of the Filecoin network, because that's probably where you fall right now. I don't think there are many teams that are standing up their own mining operations this weekend, though maybe it's something that you are actually exploring. But I'm going to talk about the client side demand, because I think that there has been a lot of work to document the miner side of this market, but the client side actually is super interesting and has some really neat dynamics going on right now that are going to lead into how this network operates over the coming years and are interesting to take into account when you're thinking about how you're using this data storage and what kind of opportunities there are to build on this network. And then the so what section, why this is interesting and why potentially you want to care far beyond this weekend, and at least keep an eye on it, if not continue to build on it. So IPFS to Filecoin. So if you're already building, or if you made it to my workshop on Thursday, hopefully you're starting to get a pretty good sense of what IPFS is and what it does. But I'm going to kind of pick out some of my favorite parts now. And so it's helpful to think about IPFS as a stack of technologies. And those technologies enable content addressing over a distributed network of peers. And the way that you can use that network is through peer-to-peer, so multiple peers running their own IPFS nodes, and then a bunch of helpful tools that you can think of like exit nodes from that peer-to-peer network. And so typically you interface with those through a gateway. And so I'll kind of go into each of those. But then the really important thing that I'll get to at the end here is that IPFS, the network, has a really bad memory. It's not really meant to remember things. And we can talk about that. So let's talk about some of the good bits, or some of my favorite bits about IPFS. And the first one is content addressable data. This is a really radical shift from the way that we, or the technologies we use, leverage the internet by default. And so the way this works is that data, when you add it to IPFS, is given a content address. And what that content address is actually a representation, a cryptographic representation of all the data within that file. And so here's a really simple example of this image of a cat being broken up into a tree of its bytes, and then those bytes actually are given a content address. And so the way that actually works, I won't get into in this talk, but it basically, everything is a graph. And at the root of every graph, there's an address that represents all the children underneath that root, and that address is derived in a way that it's unique in the universe, more or less. And so that address is actually used to represent the cat. So here on the right of this graphic, there's this rotated address, and so that hash, that address, is unique to this cat image that was the input. And so you can't take this hash and turn it back into the cat input. You can only take this cat input and turn it into the address. But what it means is that anybody that's holding on to this cat original input data can get that same address. And that means if you ask for that address from anybody that's holding that cat image, they'll know if they have it and they can return it to you. And so IPFS uses this idea across the entire network so that when you're requesting things, you're requesting them by that unique address. And the result of doing it this way is really powerful. One of the sort of great outcomes of this is that this data is self-verifiable. So that means if you ask for this cat image from somebody, you're going to send them this address. They're going to say, yeah, I have the data that creates that address, and start sending it to you. When they've sent it to you, you can take what they've sent you and run this same method to generate the address, and it should match what you asked for. So what's great about that is you can now, with 100% confidence, know that the thing they gave you is exactly what you asked for. And that's really powerful. And so the whole network, like I keep mentioning, uses this throughout. And so if you're using IPFS now, you're running into it. And if you want to know more about that graph and how the hash is calculated for every byte of data or every piece of data, and how a file gets its own unique hash, definitely go check out Proto School. I'm sure people have shared it already this weekend, but their lesson on the anatomy of a CID. So CID is that content address identifier, that hash. Their anatomy of a CID tutorial is really great and worth going through to figure out how that works if that's what interests you. But then once you have that hash, you have the cat, I have the cat, I have that hash. How do we communicate to other people that we have it? How do they find it from us? And so this is another really interesting thing about how the network works. And so there's a few different ways to unpack this. Some things that you should be aware of are the way that two peers on the network interact. And so the way that you can request data from me, and then we'll actually go through a little back and forth in the protocols inside of IPFS, and then I'll start sending you that data in a way that you can verify actually as I send it that it's the thing that you asked for. That piece of networking is really powerful, and it's actually used beyond IPFS as well. Also, there's the gateways, which I mentioned before, and that's just so that anybody with an IPFS node hosting that cat can actually tell people how to get that cat without hosting their own IPFS node. So if I need you to go get that cat now, and I don't want to have you set up an IPFS peer that can speak all those protocols inside, I can actually tell you a gateway, which is just a server that runs on the internet, and I can tell you I can give you that hash, and you can go to that gateway and make a request to that gateway for the hash. And behind the scenes, that gateway will go and go across the network to find it and pull it back for you. So it allows you to sort of skip the overhead of running your own IPFS node. It has some drawbacks in that you're not able to participate with the full IPFS network, but the benefits there in a lot of use cases are worth it. And then the final piece that I'm not mentioning here is the DHT, and you're probably finding the DHT in some of your reading, but it's the way that I could find the cat. If I knew the hash, I could find the cat and somebody who's hosting it on the IPFS network. The DHT is actually a piece of technology that's likely going to be in a lot of flux over the next couple of years as those methods are improved and alternatives are actually put in place, because persistent storage is now a thing through Filecoin and other networks. So really, I think that the peer-to-peer networking here and the gateway concept are both really powerful and will be for a long time. libp2p, related to that, the peer-to-peer, there's a whole nother library that when you use IPFS, it's very core to the way IPFS works, but it has its own independent life, and it's called libp2p. And it actually sort of is a sort of a broad net that they capture a lot of different protocols in to enable you and I to connect in as many different circumstances as possible. So however you're running your node, however I'm running my node, whatever the network situation is between the two of us, we can find whatever possible protocol can get me to you and you to me. And that's actually used in IPFS. It's also used in Ethereum 2, for example. In ETH2, libp2p is being used. So a really powerful library in itself, and so worth checking out if you haven't already. And so IPFS is gaining really broad and deep adoption, and it has been for years. So like I mentioned, ETH2 now looking at, or now using libp2p, and also examples of it being used in more traditional industries. So experiments at Netflix for distributing containers. The Brave browser uses it natively. Really amazing applications like Audius that use IPFS for moving data around their network. But one of the challenges of IPFS is that it really has this memory of a goldfish. IPFS, I like to think of it like the content distribution layer of the decentralized web. And so it's really good at saying, I have this data, how do I get it to that person? Or I need this data, how do I find it from other people that might have it? It's really good at solving those problems. What it's not really intended for is for you to necessarily push data to the IPFS network and have that network just remember that data forever. Instead, what happens a lot is that if you make data go through the network will have a really small memory. It will be cached out there by other nodes on the network. And then over time, it will actually just be naturally flushed out of the network's memory and you won't find it again. And there's solutions to this. So you can run your own IPFS peers. We do that at Textile quite a lot. So you run your own IPFS peers that you do what's called pinning, and that makes it persistently stored on your peers. And then other places, other peers on the network and other gateways can find that data on your peer that you're part of the network. But what if you can't run a peer? You're not going to create long-running infrastructure. So another option that people use are pinning services. So it's the same thing. Somebody else is running long-running IPFS peers. You're pushing data to them and asking them, "Hey, pin this for me." And that's a pretty sort of Web2 approach, right? You're going to kind of create an account and you're going to pay them some fee to pin data. And so there's a lot of companies that actually do this. So you might have already hit Infura or Pinata, or if you're using Textile, you'll know that Textile has its own concepts of pinning as well that do this at the end, sort of at the end. So if you're using buckets and you're pushing them to the Textile hub, that's essentially a pinning service, just not in the raw pin sort of way. You're pinning entire buckets. But those are solutions, but they're sort of orthogonal to IPFS itself, the network itself. So this is where Filecoin really comes in. And Filecoin is enabling trustless data storage for the peer-to-peer web or for the decentralized web. And so if you haven't had a chance to dig into Filecoin, or if you haven't made it to the other workshops or other presentations this weekend or at the end of last week, I'll just give you a little bit of information about Filecoin, but I think I'll probably also share some ideas that are slightly different than what you heard in those other talks. But Filecoin's end game is really to create a globally distributed storage layer on the decentralized web. And so it's supposed to enable sort of self-assembling storage providers, what they call miners, to launch across the world and store data according to the different sort of niches and demands that different places have. And so this is quite different than the way, say, storage works on a cloud provider, where maybe they have a dozen or 100 server farms, essentially, where you can push your data to. In this way, it's supposed to be much more fragmented and much more broken up, many miners all over the world, where you could potentially in the future have a miner that just runs in your building and is storing all the data that's needed by the people that live in your building, so that it's really close proximity and quickly served to you. The way that miners operate on the network is that they commit sectors for storing data to the network. And the way sectors are rewarded, or the reason that sort of miners are incentivized to commit these sectors to the network is because they're rewarded for doing that. And so they're actually rewarded in a number of different ways. But you can think of it like they're rewarded for empty sectors. They're rewarded for how much of a sector is filled. And then they're rewarded for how much of a sector is filled with what's called verified data. And so each of those has sort of a different reward factor, with unfilled sectors being the least but still rewarded, and then fully filled sectors with verified data being the most. And so miners are incentivized to commit empty storage space to this network because they'll actually have a higher probability of winning block rewards. So just like Bitcoin miners can win rewards by mining blocks, Filecoin miners can win rewards, and the probability of winning those rewards is increased by the number of sectors they have committed to the network. Then they're further increased to store data in those sectors because it would increase the probability of their winning sectors even more. So that they don't have to do that, but they're incentivized to do that. And they're even further incentivized if you're going to pay them to put data in that sector. But what's really interesting is early on in the network, we're seeing that those rates are dropping really low. So a miner is happy to store data for nearly free because the value they gain from filling their sectors due to the probability of winning blocks is great enough that that offsets the cost of actually storing your data. So that's a really interesting property of the early Filecoin network that you, if you're building an application or hacking on something, can actually tap into and leverage in order to get an advantage over somebody who's using, say, a traditional storage system. So when a miner wants to fill their sector, they pack it with your data, and this is back to verifiability and similar to the way IPFS addresses are verifiable. There's a lot of different kind of proofs and verifications that have to happen with your data. And so in Filecoin, there's a method for breaking up your data so that it can then be used to prove that, yes, they received your data, and yes, it's filling this sector, and then over time, continuously prove that it still exists in a non-corrupt state. And so there's a whole lot of work here, but if you start using Filecoin, you might see some ideas here around car files or payloads or payload CIDs. Just understand that that's what happens. The raw data gets transformed into this kind of Filecoin compliant data structure to be stored and proven against over the future. And miners are blockchain, and so so Filecoin, the blockchain, is sort of organizing this marketplace of storage providers, and those storage providers are operating on the chain such that they prove that they have storage space, and then they prove, when you're storing data with them, they prove that they've replicated your data, and then they prove that they've stored your data. And so that all happens through interactions with the blockchain. And when the miner does that, that's how they sort of remain. You can essentially think of it like they remain compliant with the network. And so, for example, if you want to store data with a miner and you've agreed to pay them, say you're storing a lot of data and you're paying them 1/10 of a Filecoin, that Filecoin is actually locked up, and the miner won't get it until after they've completed these sort of proofs with the blockchain. And so that through these mechanisms is how this vision of the network kind of unfolds. And what's really amazing to think about is that all of those things, before you even enter the scene as a client wanting to use this data, means that Filecoin is actually the coin itself is operating as a supply side coordinator. So the motivation to mine these blocks is organizing a huge number of miners to commit storage data to the network. And so what's really amazing to think about is that Filecoin is a multi-sided market. So if you've ever thought about starting a startup, you'll quickly run into literature about two-sided markets and how challenging it is to bootstrap two-sided markets. And so I quickly think of like an Uber, where it's a great case of a two-sided market where Uber would have failed if it couldn't find riders. But similarly, it can't find riders unless it can find drivers to drive them, right? And so it has to somehow bootstrap these two sides of the market simultaneously, or none of it works. And so usually that takes a lot of capital to do, is really one sort of hack around it. But Filecoin has actually done it by having these crypto incentives for miners. So the early Filecoin token, being really the supply side organizer, has actually created a huge influx of storage capacity on the Filecoin network. So it's actually over 5.5 exabytes of storage data have now been committed to the network. So since launch, that's like 4 million, 5 million gigabytes per day of new hard drives being committed to the network, which is really just a huge number and something to be pretty interested and excited about if you're a builder who wants to tap into data storage. And so back to the Uber analogy, and you look at sort of the valuations of different ride shares and think about where this is in the growth of Uber. The big difference here is actually if Uber had launched and the day that, if you were in New York City, say the day that Uber launched and you'd stepped outside and there were only black car Ubers in the streets, and you could have hailed a ride in under 2 minutes to any place else in the city. It just didn't unfold that way. But here, because of the way that this system is designed, it's really unfolding in a very radically different way, which again is really interesting. And there's a lot of use cases for it that are starting to emerge that want to tap into this storage space in interesting ways, and a lot more. And so I kind of want to just make the point here that one reason this is interesting for people that want to build on other blockchains is that other blockchains just aren't designed to optimize around storage. And so storing data in smart contracts in other blockchains just doesn't scale. It's not really meant to work that way. And so the convention on most other blockchains is actually to use IPFS CIDs, which map to data on the IPFS network. And now we can start thinking about mapping data to data stored on another storage network. And so there's really cool projects like NFT.storage that are doing just that, working with, say, Ethereum developers to map IPFS-based CIDs to deals on Filecoin. And there's a lot of other really interesting client applications here that are being built. And I encourage you to check out Textile's documentation as well, because we have a number of different products that are building on Filecoin and let you kind of tap into it. And one of the ones that I think is really exciting is one that we're building as we haven't really spoken about this much, but it's an example here where we're building a bridge to other blockchains. The first blockchain that we have running is actually Near. And so here, allowing a dApp developer to more or less embed Filecoin storage directly in a dApp so that there's no user accounts, there's no API keys. The dApp user can actually just authenticate with their wallet and begin uploading data to the Filecoin network. And we think this is going to be a really interesting shift in the way that application builders or NFT creators or DAOs themselves are organizing around data and using the benefits of one blockchain to tap into the benefits of a blockchain like Filecoin. Okay, so I think that's all super exciting, and I'm happy to talk about more of it in our Discord channel. You can find the Discord Textile channel. And if you start building on this stuff this weekend and want to build longer, I'd love to have you join our Slack channel, for example, and share with us what you do. And I'm always interested in that. But what's the bigger picture here? And I wanted to just kind of step back for a second and reflect on why a decentralized storage network matters, and why thinking about these new approaches to storing data in these permissionless ways are really interesting. And so this is from an old blog post of ours where we were talking about the proliferation of data that you and I all emit. And so if you think about the early days of sort of the internet, even maybe you had an email address at a university, and so the data that you were creating on the internet included encrypted messages in your mailbox, maybe an email handle, maybe some basic IP logging, but really small amounts of data. And as we've gone through time, the amount of data that you and I are emitting as human beings has just grown exponentially. And that's really interesting because it's pretty clear that we're crossing, or we're about to cross a boundary where most of human interaction is happening in the digital space, which means most of the output that you create is actually data about yourself, about your interactions, about society. And that's really interesting. And as Yuval Harari said, we're running on ideas of the 18th century. So if you think about a society that is running on ideas of the 18th century, but has just over the last 10 or 20 years transitioned into a society that is predominantly digital, that leads to potentially big problems. And so one of those problems is that there's actually seems to be an emerging literal war for data right now, and the war has many actors, and you can see those actors both in private companies that are working very aggressively to capture as much data about us as society as possible. And it isn't really the data that they care about, it's actually the information layer that they can create on top of that data. And so you can see sort of the arms race happening here around creating machine learning and AI workflows to turn information or turn data into information, but they need to capture as much of that data as possible. But that war is also playing out in sovereign states, and you can see that the way that states are sort of aligning around the way that they're censoring companies, the way that they're banning access to applications for their citizens. And this sort of internet fragmentation is another real strong signal that this literal war is happening around data, because data means information, and information is sort of control and power and many other things. And so this is something to be really aware of, why this is important that we're building what we're building, and that we sort of can take it to the future. And I think we can change this, and we can help define the future. And it's through these experiments that you're doing this weekend, and being conscious of how do we build things that are positive for the future? How do we build things that reinvent the way humanity can interact with data and take us from that 18th century humanity into this sort of new society where we're going? And thinking about how you really make data and our relationship with it something new. And I'm really excited about that. And we can see this playing out in the sort of crypto and decentralized spaces. And I'll point to Alex Gladstein's work and a lot of his writing in the Bitcoin space. And sometimes it can be controversial to people because he's very, very Bitcoin pro. But I think his points are all really interesting and important, and definitely worth looking at. But he's spelling it out from a very literal sense that decentralized payment means freedom in a lot of places. And if we can push it harder and get it into more of society's hands, it actually has the ability to battle authoritarianism. And so that's really powerful. And I think just in that sort of wavelength, decentralization and decoupling sort of control and power from the data that we create is critically important. And there's a really great blog post from Chris Dixon that spells this out, called Why Decentralization Matters. And this relationship between platforms and users needs to be broken away from sort of the value capture that is enabled by companies capturing as much data from us as possible. So definitely worth a read as well. And I'm saying all these things, and they sound maybe stark a little bit, but I really think that this could actually get a lot worse. And the reason I think it could get a lot worse is because a lot of power, both in countries and in corporations, has been built up around these silos of data specifically. And so I'm not going to touch the decentralized payment piece, but if you think just around the power that's been built around data, if we radically change that, I think that the battle has only just begun. And I'm actually really excited for where that's going. And I really want to invite you all to explore that with me and figure out how we get there, and how we can build the new technologies that circumvent that power and redistribute ownership of data back to users and change our relationship with the internet. And with that, I just wanted to point out one thing, which is amazing, which is I'm really excited about networks like Filecoin. And if you look at Filecoin, it's only 200 plus days since mainnet. And already it's come so far, and there's so many ideas you can imagine on it. So if you're really just getting started in this space, you're barely behind everybody else that's here. And so there's so much we can all do together. And so I invite you to keep hacking with us. And with that, you can find me on our Discord, on our Slack. And like I said, we're hiring. So thank you very much.
Awesome. Thank you so much, Andrew. That was a great presentation and such an inspiring note to end on.
Cool.
If anyone has any questions, I think we're just about over time, so perhaps we could take it to the Textile Discord channel. Perhaps that makes sense. Okay, perfect. Awesome. Thank you so much, Andrew.
Thank you.